Arithmetic sequences. All right, so today we're going to talk about arithmetic sequences, and you're going to learn how to write the terms of an arithmetic sequence, graph an arithmetic sequence, identify arithmetic sequences, and write arithmetic sequences as functions. So there are two important vocabulary terms that you need to know. One is an arithmetic sequence. Obviously, you need to know what that is if we're going to be working with it. So in an arithmetic sequence, the difference between each pair of consecutive terms is the same. And here's an example. If your sequence is 5, 10, 15, 20, you can see that you add 5 each time. That is a common difference. So if you have this common difference, if you add or subtract to get to the next term, you have an arithmetic sequence. Common difference. In an arithmetic sequence, the difference between each pair of consecutive terms is the same. That difference is called the common difference. Example 1, extending an arithmetic sequence. Write the next 3 terms of the arithmetic sequence. All right, so you can see it gives you 4 terms. This is your first term, second term, third term, fourth term. So the first thing we have to do is see if there's a pattern, see if there is a common difference here. So how do you get from one term to the next, and to the next, and to the next? So from -7 to -14, you're going to add -7. From -14 to -21, again, you're going to add -7. And from -21 to -28, you add -7. So if you want to find your next 3 terms, what do you think you're going to do? If you said add -7, then that is correct. So your next 3 terms would be to add -7. So my next term would be -35. And then if I add -7 again, I would have -42. And if I add -7 again, I would have -49. And you could continue that pattern as far as you need to, but it says to write the next 3 terms. So that's what we did. Example 2, graphing an arithmetic sequence. Graph the arithmetic sequence 4, 8, 12, 16, etc. What do you notice? All right, so we know this is our first term, our second term, third term, fourth term. So let's make a table of values. So we've got 1, 2, 3, 4 terms. So N is going to be which term we're looking at. And then A sub N is the actual number. So we're going to have 4, 8, 12, and 16. Now we can take these and look at them as ordered pairs and graph them. So we have N across the bottom, that's like your X, and then A of N, A sub N, that's like your Y value. That's up the Y axis. That's your vertical axis. So we've got 1, 4. So 1, 4. Let's put a point there. And then we've got 2, 8. We've got 3, 12. And then we've got 4, 16. All right, so it says, what do you notice? You can notice that these points fall along a straight line. So this is going to represent a linear equation or a linear function when we start looking at how to write them. So that's important to notice that this is a line, and you could continue that if you used, like what we did in example 1, if you used the common difference. You can see that each one is added 4. You would know that the next one would be 5 and 20. Example 3, identify an arithmetic sequence from a graph. Does the graph represent an arithmetic sequence? Explain. Well, it looks like a line, and it looks like these numbers are spread evenly. So I'm going to assume that it is based on what it looks like. But let's look at the terms. So we have 15, 12, 9, and 6. And then I'm sure that we could make that continue. But to go from 15 to 12, we're going to add -3. 12 to 9, we're adding -3 again, or subtracting 3. And we're going to add -3 again. So since the consecutive terms have a common difference of -3, we know that this does represent an arithmetic sequence. Example 4, finding the nth term of an arithmetic sequence. All right, so it says write an equation for the nth term of the arithmetic sequence. And it gives you a sequence, 55, 40, 25, 10. Then after we write the equation, it says then find a sub 16, so the 16th term. All right, so we have 55 to 40. That means we're going to subtract 15, or we're going to add -15. From 40 to 25, we do the same. Add -15 and add -15. So we can conclude that our common difference is -15. All right, so what we're going to do is look at the equation that goes with an arithmetic sequence. So it says let a sub n be the nth term of an arithmetic sequence with the first term a sub 1 and a common difference of d. The nth term is given by a sub n equals a sub 1 plus n minus 1 times d. So we've already found d, our common difference. So we're going to say a sub n equals a sub 1 plus n minus 1 times d. All right, so for now, we're just trying to write an equation. So we're not going to worry about the 16th term just yet. So let's say a sub n equals our first term. We can see that as 55 plus n minus 1 times our common difference, which we found to be -15. Now, you can rewrite this a little bit. This looks a little different than what we're used to, but you can rewrite this and it's going to look similar to an equation we learned before called slope-intercept form. So if I take -15 times n, that's going to be -15n. -15 times 1, or -1 is +15. And I can add that +15 to 55 and get +70. All right, so again, I just use distributive property, and then I combine like terms at the same time. So if you remember y equals mx plus b, this is the same type of equation. We're just using n in place of x, and we're using a sub n in place of y. Now, the second part of this question says find a of 16, a sub 16. So we're going to say a 16, that means your 16th term, and we're going to take the equation we just found. So we have -15 times n. N is going to be 16 in this case, and then plus 70 is the rest of our equation. All right, so we've got -15 times 16 is going to be -240. And then -240 plus 70. It's going to be negative 170, but let's add that. Make sure my mental math is correct. Negative 170 is correct. Good. So that is your 16th term. And this is the equation.